Hello, this is video BB, and this is going to combine two of your favorite things, structures and pointers. Structures are collections of variables of possibly different types that typically all the different variables have to do about one particular thing, one object. Pointers are those weirdo variables that hold addresses of other things rather than holding a value that we want to use on their own. And I'm going to try real hard to behave myself and keep the code and the definitions and so forth on this half. So I've got that room for pictures. It's an experiment. I'm going to see how much of this stuff I can keep on the board at one time. At any rate, I'm going to start with the note, put it way up here so it doesn't take up much space. Structures can point at other structures. They can point at each other. I'll abbreviate. Structs can point at other, I'll spell it out this time, structures. I should have spelled it out both times, but I'm sorry I didn't. Structs, short for structures. Structs can point at other structures, even of the same type. And since that's a surprise, I put an exclamation point. And we'll look at some examples. That note is in the way now. Now I'm going to start looking at C++ code and writing it here and talking about it over there. That's my plan. We'll see. I'm going to call, well, actually, I need the structure first. Here's an example. STRUCT. I'm going to call my structure city. I'm planning my summer tour of the United States or whatever. And I'm only going to put two fields in this structure. That's all I need to show what I'm going to try to talk about. We need the name of the city. String name. And I want a pointer to a structure of the same type so I can connect my cities together. And you'll see what I mean in just a second. I've got to do it like this. City. Believe it or not, the compiler's already seen city with a capital C, so it knows it's a data type, it's a structure, and already, even inside the structure itself, I can refer to that, except I'll have to use a pointer, and that's what I want to do anyway. This is going to be next city, semicolon. The big fat semicolon down here, because sometimes we forget to put them after the closing curly bracket. Now, I'll put a picture over there to show what we have so far, even though I'm afraid I'm going to have to erase it when I get serious about drawing pictures. And I'll have a picture drawing color. I'll try blue, see if this is dark enough. Here's a fig. Fig to go with that struct that we just now set up. Remember, I make those dotted boxes, my own little convention. Dotted boxes mean it doesn't take up space in memory. All we've done is design what this new data type will look like. If we get around to actually defining any variables of type city, I hope you can see that. Maybe I should be using a darker blue, but I'll continue and maybe have to restart this. Name, colon. That's this. That's going to be a string, the name of the city, Memphis or Washington or New York, whatever. This is the weird one. Next city. Next city itself will be a pointer. A pointer, which is a hexadecimal address that points at another city structure somewhere else. So it doesn't really have a value we could use directly. It tells us where another city lives in memory, if we think of it that way. Now, moving right along. Now that I have the structure, I'm going to set up just a plain old standard structure that we know and love, that we've dealt with for dogs and cats and all that other stuff. And I'll even call it a standard structure variable. What might that look like in my main program? City with a capital C, brand new homemade data type. So city with a capital C, I'm going to call this variable start. My starting point. Where am I going to start on my tour of the country? Well, I'm going to start in Lexington. Now that I have the variable, I told you I was going to have to erase this, and I am. But now that I have the chance, I'm going to go to a darker color. Purple, that'll work. If I can get it. Okay, so now I have a city called Start, S-T-A-R-T, and I make that a solid box, because it's real, that takes up storage and memory. And just by virtue of this statement alone, it has a name variable inside it that's currently garbage. If I put the question mark, I'll just have to erase it, but just remember that's garbage. And also, it's got a variable or a field called next city inside it, which is also garbage. So, I have a variable, I just haven't filled it in. Let's fill it in. I'm going to say that city.name, whoops, not city, good grief, start.name equals, and I'll abbreviate because I'll probably misspell it, Lex. The airport definition. Well, we'll put Lex in as the city name, and while I'm over here doing assignment statements, I'm also going to set start dot next city to 0. Why would I do that? Well, it turns out 0 is not a valid memory address I can use in my program at all. I use 0 as sort of a dummy value to put in there to say, you know what? At the moment, the next city variable does not have a meaningful value that I'm allowed to use. It's a convention. You don't have to do that, but it certainly makes your life easier when you're working with pointers and programs if you get to assume, because of convention, that any pointer variable that's not currently in use has value 0. You can use it to test in an if statement, in a while, whatever. So the name is Lex for Lexington. The next city currently is 0. So far, so good. I hope. Here's a dynamically allocated structure. That means the structure that I'm about to start using in my program at the moment does not have any storage that my program is allowed to use. I'm going to, well, let's see. First of all, I'm sorry. I'm going to go back up here and change start. That's not a semicolon anymore. That's a comma. I'll just smear it. Smear it and put a comma. Start, and I'm going to call this other city, I'm going to call that finish. My final destination, or at least the next destination. So in addition to start, I want finish, but I'm going to put a star in front of finish. And then the semicolon. Now I'll be very careful to try to explain this very deliberately. What this means is start is the whole package. Start is the name of a structure variable that has all those pieces in it that we define right here. Finish is not. Finish is a pointer variable, meaning for one thing, it's a much smaller variable. Here's finish. It's supposed to be in purple. I'll switch to purple. Finish looks like this. It's a little bitty thing compared to a great big structure with lots of pieces, because all that's got to hold is the hexadecimal number that's the address of a city structure. At the moment, it doesn't point at any city structure. Let me switch back and try to use the right color. So I have an actual city structure variable. I have a pointer to a city structure variable, and now I'm going to use a pointer to city structure variable. Finish equals new city with a capital C. Anything that's a data type that the compiler already knows about, you can tell the system using the new statement. You can tell it, I want a chunk of storage that's big enough to hold this thing. So it doesn't matter how large city is. It could be hundreds of bytes. Maybe we've got lots of fields in there. It doesn't matter. The system will go in search of a chunk of storage that's not currently being used by your program that's large enough to hold a city structure. Claim it. I now pronounce this chunk of storage as being used by program X, or whatever this is. I now mark that as being used by this program, and then return the address of where it found a place for this new city, and that address is going into finish. Holy moly, that was a lot of pieces. Here's what they look like. On the right-hand side, when the system, is evaluating this assignment statement, oh, where is it? I don't know. I found enough room for a city right here with all the pieces, the name and the next city. I'm so proud of myself. Not only did I find storage way down there for you that lives at hexadecimal made-up value D07E. Could you tell I was making that up as I went along? I was. So it found that is a structure, but unlike start up here, it's not a structure variable that has a name. It's just sitting out there taking up space that belongs to my program now. And this is going to return the address of where it claimed that storage. We're taking that address and putting it in variable finish. So now finish does point. It does have its very own city structure. Right there. Now, there are a couple of pretty profound implications of that. One thing, this city structure that now is a part of my program has no name. Unlike start up here where I could say start.name and get lex. Start.nextCity and get that 0 if I wanted to. There is no variable name down here, variable name.city. I'm going to have to get at it indirectly using the finish variable. And I know you're wondering, how do I do that? You do it like so. Finish arrow. That arrow, it looks like a real arrow on my whiteboard. It's actually a minus sign followed by a greater than sign. You construct an arrow in C++ syntax. Minus greater. Finish arrow name equals, wherever we want it, let's go to Dallas. I think I can spell that. D-A-L-L-A-S. Double quote. Big deal here. Up here, I said start dot name. Start dot name. Every time we use structures up to this point, we always use a dot to get at the piece of the structure that we want. Not down here, we can't use the dot because finish itself is not a structure variable. Finish points at a structure variable. Even more wild and crazy, it points at a structure variable that doesn't have its own name. And I just realized that name is a bad name for a field in there, and I'm sorry about that. Finish points at a structure variable that the variable itself has no name, like start. So we have to access it indirectly, and the C++ notation to do that is the arrow, showing that, yeah, we know that we are pointing at, good grief, how many different ways can I say the same thing? Dallas is the string that's on the right-hand side. Dallas gets put into finish arrow name. Now, the cool thing about drawing pictures like I do is not only does that make you an artiste, but whenever you see an arrow in your C++ code, you get to follow an arrow in your picture. How cool is that? Oh no, where's Dallas going to go? It goes in finish arrow name. Watch this. Finish arrow name Dallas. Wasn't that fun? Want some more? Want some more? Let's go. Finish arrow next city equals 0. Let's try it. Finish, follow the arrow, find the next city, put a 0. Finish, follow the arrow, find the next city, put a 0. Done and done. Now, just to make things even wilder and crazier, first of all, let me reflect and review. This is important. If you have an actual structure, a structure with a name, for crying out loud, use the structure's name, dot, and then the field you want when you're trying to access it. If the variable that you're using does not have a name of its own, I do not have a name even though I'm a variable that takes up space in memory. All I have is an address. No one gave me a name. Then you have to access it indirectly through a pointer. Finish equals new city gave us a chunk of storage just large enough to hold the structure. And we had to access the name field and the next city field indirectly. Here's the watch this part. I'll even put a comment there. Watch this. Hold my coffee. Away I go. Start dot next city equals finish. It's going to be a short trip, but I'm running out of board space. So we'll say you go to one place and you're done. Yeah, this summer would be the summer for it, huh? Start dot next city. Start dot next city right here. Right now it's a 0. What are we putting there? I'm sorry, I should have started on the right-hand side. Right-hand side, evaluate that. That is a variable that has a value. The value of the variable is D07E in my make-believe world. So we get the value of variable finish, hexadecimal D07E, and put that at start.nextCity. D07E. Copy that into start.nextCity. That's not a 0 anymore. It's hexadecimal D07E. It's almost a little rhyme, I say, to myself and people that dare listen to me. Copy a pointer to a pointer, you get 2 pointers pointing to exactly the same thing. It's not quite a tongue twister, but you copy one pointer variable to another pointer variable, you end up with 2 pointer variables with 2 arrows pointing at exactly the same thing. Not a copy of that thing, no. They're pointing at the same thing in memory, because there is only one memory address, D07E. So when I copy this pointer, which I can see is a pointer, it's defined as a pointer to a city structure. I copy that to another pointer, start. The start variable is a structure that's got a pointer to a city variable inside it. So I am doing that. I'm copying a pointer value to another pointer value, copying variable to variable. I end up with 2 pointers pointing to exactly the same thing. You might not think that's any big deal, but it's kind of a big deal because I can now do this. Cout, less than, double quote, final destination. Wow. Final dest. That sounds kind of ominous. I hope we could go further than that. Final destination, less than. I have more than one way to get to the variable that has no name. I'm going to get there this way. I'm going to go through the start. Start is the name of the start structure, the starting city. Start dot next city. Arrow name. And less than indel. What did I do? Well, I'm printing out final destination. That part's easy. I think I just marked on my shirt. Here's the hard part. I did this on purpose. This uses 2 different notations that we have to use with structures. One of them when we have a structure variable itself. The other one when all we have is the address of a structure, a pointer to a structure. Start dot next city says go to the start structure variable dot next city chooses this field. The arrow says now follow where that address leads you and find the name. So arrow in the code, arrow in the picture, follow the arrow, find the name, and this is going to say final destination Dallas. Okay? And I didn't do it. I want to put some more stuff, but I'm going to have to do the wraparound thing. In your notes, you could put it correctly. Dot, dot, dot down here, dot, dot, dot coming in from above. Imagine, if you will, that I've wrapped around and now the next line goes after that one down there. What is it that I want to do? I don't think I want to do that. I am done with Dallas. I printed it out. I just wanted to say where I was going to go. So I don't want that anymore. I can get rid of that whole structure at one time. I just use that delete command. Delete. Not delete Dallas. Delete finish. Let me catch up. That does not get rid of the variable name finish. The variable name finish is going to live as long as this is in the main program. Finish will live as long as the main program. It's not going to come and go. I explicitly asked for the city that finish points at. So I explicitly have to give it up. I have to relinquish that storage when I'm done with it. So that's what delete finish does. It says get rid of whatever finish points at. So it doesn't get rid of variable finish. I don't X that out. I accept that. Now, by convention, careful convention, and I'm sorry this all got squashed and wrapped around and everything. Now that this got returned to the system, that means all of a sudden I've got 2 pointer variables whose variables are not valid anymore. And I can do these in any order, but I need to do it before I forget. Finish equals 0. There. I won't accidentally try to say finish arrow name anymore because I'll test it before I use it. If finish is non-zero, then print out finish arrow name for me. See how we could use that? So I'll check and see whether or not it's